Good morning, students. Today we are going to see some more two problems on the divergence theorem proof or verification. So the problem statement is there exists a spherical volume charge of radius R A with a uniform charge density rho V. Verify the divergence theorem for R less than A and R greater than A. So this is the problem statement. So first we have here two cases. One is case A. Solution case 1, that is R less than A. So for this we need to remember the uniform charge density formula for E, or in other words D. You can take D is equal to, it is R divided by 3 rho V into AR. This is the formula for R less than A. So we need to verify the divergence theorem. So we can take LHS side, that is surface integral S d dot ds. So d dot ds we can take, that is surface integral S d is nothing but R divided by 3 rho V into AR. Then we want ds. We know, we have done so many times, that is r square sin theta d theta d phi. So this is in the direction of AR. We can take. So AR into AR becomes 1. So it is nothing but surface integral S. So R, this R cube divided by 3 rho V into sin theta d theta d phi. So this value remains. So integration you have to take, that is phi ranging between 0 to 2 pi, then theta ranges between 0 to pi, then r cube by 3 rho V sin theta d theta d phi. Okay. So what answer we are going to get it here? So if you do the integration, so r is the constant term, it will be r cube by 3 outside, then sin theta is minus cos theta, that is minus cos theta 0 to pi, then phi is phi, we take, this is after applying the limits we get it is 2 pi. So the value is, so if we calculate this is minus cos pi minus of minus cos 0. So minus of cos pi it is 1, then minus of minus plus plus, then cos 0 is 1. So 2 into 2 it becomes 4. So it is 4 pi into r cube by 3 into the constant term rho V remains. So here the rho V term is there. So this is the LHS side. So next we need to go for the RHS. So what is RHS we get? RHS is volume integral del dot D into dV. So this is nothing but volume integral. So for spherical we know 1 by r square dou by dou r square into dr plus 1 by r into sin theta, that we know. So here we have only dr term. So it is 1 divided by r square into dou by dou r of here r square into, this is dr. This is dr into dv. Okay. So it is nothing but volume integral 1 by r square. So dou by dou r of r square into dr, we know, that is r by 3 into rho V. This is into dv is nothing but, we know, r square sin theta dr d theta into d 5. So this value we know. So here it is r square you can cancel it. Then so dou by dou r of r into r square. So that is r cube by 3. So differentiation of r cube by 3 is nothing but 3r square by 3. So it is volume integral 3r square by 3 into sin theta d theta dr d phi. Okay. So one more term is rho v. Here it is rho v. Okay. So rho v is constant. I will take it as outside. Then volume integral, it is nothing but phi ranging between 0 to 2 pi, then theta ranges between 0 to pi, then r ranges between 0 to r, then here it is r square into sin theta d theta dr d phi. Okay, here this three get cancels. So it is rho v into, apply the integration for r. R is nothing but r cube by, here it is r cube by 3, 0 to r. Then this is minus cos theta 0 to pi. Then it is into 2 pi. Okay. So here if I substitute r, this is again r cube by 3 into rho v. This term or second term becomes 0. Then here this term, it is 2 minus cos theta 0 to pi. This becomes 2. 2 into 2. This is 4. That is 4 pi divided by 3 into r cube into rho v. So this is the LHS side. So LHS equal to RHS. This proves the divergence theorem. Then one more case 2. Case 2 is nothing but, here R is case 2. R is greater than A. So for R greater than A, we have the D formula. D is equal to A cube into rho v divided by 3 r square into AR. This is the D formula. So when R is increasing more than A, means R tends to infinity, comma, the D tends to 0. Okay. So this is also verified. Therefore, the surface integral S d dot ds is equal to volume integral v dot d into dv. Hence the proof. Means this becomes 0. So this is the second case. So we will take one more problem this in the same lines. So the problem statement is, we have given problem second, we have given T is equal to 5R into AR coulombs per meter square. Prove the divergence theorem. Prove the divergence theorem for a shell region enclosed by spherical surface at r equal to A and r equal to B, where B is greater than A and centered at the origin So this is the problem statement. So the solution is, again we have to find d dot ds, that is first part. This is LHS. LHS we need to find, that is integration d dot ds. So d dot ds is nothing but surface integral. Directly I am going to write phi ranging between 0 to 2 pi, integration theta ranges between 0 to pi. We have the dr value. The dr value is 5 into r. So this is multiplied by ds. Ds is r square sin theta d theta t phi. So it is nothing but what? R into r. This becomes r into r square, that is r cube. So phi is 0 to 2 pi, theta ranges from 0 to pi, 5 into r cube sin theta d theta t phi. Okay, so this is the given value. The d we have found out. So the r range they have given, that is when r equal to a and r equal to b. So if I substitute r equal to a, first r equal to a, if I substitute here, what I am going to get here? It is 5 a cube, then sin theta minus cos theta. This is integration cos theta 0 to pi, then d phi is, it is 2 pi I am going to get. So it is nothing but what? How much you are going to get here? It is, here it is 5. This value becomes 2. 2 into 2, 4. 4 into 5. 4 5s are 20. So it is 20 pi into a cube. If I substitute a for r equal to a, this implies. Then for r equal to b, this implies what? Here it is 5 into b cube minus cos theta 0 to pi, it is 2 pi. So it is nothing but what? 20 pi into b cube. So these are the two values. So it is a shell having the two regions. So I can subtract one from another. That is the total integral t dot ds. It is nothing but what? Subtraction between that b and a. So it is 20 pi b cube minus a cube with b is greater than a. So this is the value I got. The same value we have to prove in the volume integral. So what the volume integral states? So for RHS side, for RHS, it is nothing but volume integral v dot d into dv. So it is, we have only dr term, that is, so volume integral phi range between 0 to 2 pi, then theta ranging between 0 to pi, then r value range between, it is a and b. We have the limits, that is sphere limits we have a and b. So it is 1 by r square into d by dr of r square into dr value is 5, that is 5r into dv. dv is nothing but what? Again r square sin theta, r square sin theta d theta dr d phi. Okay. So here it is value is going to cancel. What value you are going to get here? This r square get cancels. So phi equal to 0 to 2 pi, theta is 0 to pi, r is a to b value. Then okay, next the value I am going to get here is, so this r square cancel, so 5r into r square, this is r cube. So differentiation of r cube is nothing but 3r square. So that 3 into 5 is 15 r square into sin theta d theta dr into d phi. Okay, so next what I will get here, 15 is the constant term, take it outside. Integration of r square is nothing but, it is r cube divided by 3 a to b. Next it is minus cos theta 0 to pi, then phi is 2 pi. Okay, next if I substitute the value, what I am going to get here, this 3 ones are, it is 3 5s are. So again 5 is there, this becomes 2, this becomes, this is already 2, 2 into 2 4, 4 into 5 20 pi, then r cube, it is b cube minus a cube. So here this value is b cube minus a cube. So again we got the same answer. So LHS is equal to RHS. Hence we proved for the divergence theorem. So next topic we will continue in the further class. Thank you.